Hello. Welcome back to our final class. We did it. We made it all the way to the end. Well, let me know who's here in the chat. Looks like there's a few of you here already. We still got a couple minutes before class starts. Good morning, Taylor. Maybe Taylor's the only one in class today. That's fine. Navik, good morning. Is that a cloud? Is that a cloud emoji? It's cloudy outside here. I have no clue what the weather is where I am because I have blackout curtains going to cut down on the glare. And when I say blackout curtains, I mean like old blankets. Great shirt. Thank you. 2004 World Series champs Hawaiian shirt. All right, we'll get started in like a minute, maybe less. Again, we're just going to review today, so hopefully there's some questions we'd like to go over. All right, well, my clock says 9 o'clock, so it's time for our last simultaneous sip of the semester. I'm trying to stall a little bit to get the viewer count up, but maybe people are sleeping in today. That's fine. So if you'd like to join in on one last simultaneous sip for old time's sake, now'd be the time to do so. That was nice. Couldn't miss the last simultaneous sip. Yeah, that's a great attitude, Taylor. What is the saying? Don't be sad that it's over. Be happy that it happened. I don't know. Good morning, Shutong. Cruz, good to see you. All right. Now, Veek joined in on the sip. Excellent. Yeah, so again, we're going to do the same thing today as we did yesterday. Maddie joined the sip. So if you have any questions you want to go over from any of the old tests or quizzes or homeworks, let me know. I don't know if you, so I posted that video a few days ago, 109 true or false questions. It's going viral. It's got like 400 views already. I've never seen anything like that from my channel. Can you believe it? But on a serious note, ask any questions in the chat, and then we could try to solve them. They could even be from the book. Good morning, Liza. If you all showed up a little bit after the simultaneous sip, just rewind the video. Then you can join in. Yeah, we could go over the last quiz, even though it hasn't been graded. Okay, I'll do that tonight. I've been behind on the grading of your homework is almost done. The last homework There's one question left, and then the quiz should be quick. But yeah, let's go over the quiz. I don't have. Can you just type in what the formula was, Taylor, for our potential inner product? And then can we do a problem like the last one we did in the notes? Yeah, sure. We'll do that next. If you have your book, Maddie, can you open up to 6.7 and see if there's an example you like? I also could do that. But yeah, so Taylor, can you let me know? Can you remind me what the formula was for this? Okay, thanks. And before we do this, Maddie, was just remind me, the last question we did in our notes had to do with like the inner product space with the continuous functions. If that's the case, there's a good example I found. Okay, so quiz 10 said that u times v was 4u1 v1 minus u2 v2, and we want to test if this makes an inner product, or if this is an inner product. Okay, so the way we test if something's an inner product is we have to show that all four of the axioms hold. Okay, so the first one, we do uv, we want to show it's equal to v times u. But these are just products, so they obviously switch. Okay, so condition 1 holds. Condition 2 would be 4 u1 plus v1 w1 plus u2 plus v2 w2. You can distribute this through. And then these two terms group up to be u times w. These two are v times w. Okay, so condition 2 holds. Condition 3 is, well, let's just see what happens if we do cu times v. We could factor out the c. And these are minuses. So I had a sign. I wrote the formula down wrong along the way. That was a mistake. These group up to be u times w. I'm sure you noticed this, but these group up to be v times w. So minus here, minus. Okay, so the first three were pretty straightforward to check. The last one was probably the one that gave you all trouble. So the question is u times u greater than or equal to 0? Right, and we want to show that, I mean, either yes or no. If the answer is no, then we know it's not an inner product. Okay, so let's write out what u times u is. U times u is 4 u1 squared minus u2 squared. And this, like, we're asking, is this always greater than or equal to 0? Well, the answer is no, right? If u equals, let's say, 0, 1, if u is the vector 0, 1, oops, not the inner product 0, 1. If u is the vector 0, 1, u times u would be 0 minus 1, which is negative 1. So this is not an inner product. Does that make sense? Yeah, so I tricked a few of you. Right, because this is very similar to an example we did in class. But our example had a plus in class, right? If you add two non-negative numbers, it's still non-negative. But if you take their difference, it could be negative. Okay, so you do have to be careful. You know, every once in a while, we got to think. We got to think a little bit when we're going through the steps. Okay, could we do another problem like the last one we did in our notes? It was construct an orthogonal basis. Yeah, let's do that. But let's, instead of going from -1 to 1, we'll do -2 to 2. And believe it or not, that's going to change the question. Okay. If we had another week or two, we could do it like in general from A to B to talk about how to construct orthogonal bases for this space. It's a little bit tricky, but it's neat. But it's not too hard when we have a symmetric about t equals 0. So yeah, we'll go. We want an orthogonal basis. Our vector space V will equal C of -2, 2. And what we want to do is first show that 1 and t are orthogonal. Okay, so that'll be our first part of the problem. So how do we show on the space of continuous functions from -2 to 2, how do we test to see if two functions are orthogonal? So does anybody remember the inner product, what the inner product was for the continuous functions? Yeah, we want to show the inner product equals 0. And just as a reminder, the inner product for continuous functions is the integral from -2 to 2 of the product of these two functions. So 1 times t, so which is just t in this case. And we want to show that this is equal to 0. Well, the integral of t is t squared over 2. Okay, and so this 1 and t are orthogonal in this vector space. So now the second part of the question. So find a third polynomial in P2 that is orthogonal to both 1 and t. Okay? And we'll call this P2. And we'll say its coefficients are A, B, and C. Okay, so we want to figure out what has to be satisfied in order for this polynomial to be orthogonal to both P0 and P1. And so we'll take the dot product or the inner product with both of those polynomials, see what equations have to be satisfied, and we'll have a system of equations with 2 equations and 3 unknowns. We know how to solve those. Okay, so let's do that. So we'll start with P0 times P2. Which is the integral from -2 to 2 of 1 times P2, which is just P2, right? We want this to equal 0, but first let's evaluate the integral. Okay, and then when we evaluate this integral, we get, okay, somebody's got to fact check me on this. 16a over 3. This term would go to 0, and this would be 4t. And we want that to be 0. Okay, so please give me a confirmation if my evaluating the endpoints is correct. But I'm fairly certain it is. Oh, sorry. This is wrong. So for C, we're subbing those in for T. Okay, now we'll do the same thing with P1 times P2. Okay, so again, the inner product of P1 times P2 is the integral from -2 to 2 of P1, which is t, times P2, which is AT squared plus BT plus C. Okay, so this is the integral from -2 to 2 of AT to the third plus BT squared plus CT dt. Which is AT to the fourth over 4 AT to the fourth over 4 plus BT to the third over 3 plus CT squared over 2, evaluated at our endpoints. This is even and this is even, so those will both go to 0. We're left with 16b over 3 is equal to 0. So that tells us b is equal to 0. MATLAB confirms. Excellent, excellent. Yeah, so this tells us b equals 0. Okay, so our equations that have to be satisfied are, I'm going to multiply a 3 to all these to make it a little cleaner. 16a plus 12c equals 0, and b equals 0. Okay, so for instance, we know b is going to be 0. You just pick values of a and c that make this satisfied. C would be our free variable here. So we could take c to be, I don't know, -4, just so we have clean numbers. And a is 3, and b is 0. So P2 of t would be 3t squared plus 0t minus 4. And so this gives us an orthogonal basis. P0, P1, and P2 gives us an orthogonal basis for the subspace, which is the polynomials of degree at most 2, which we call P2. Are we happy with that, Maddie? Or was there more to the question? I think we approximated like the cube root of 3 or something using this. So there could be many right answers. Yeah, so pick your favorite value for C, and based on that, you're going to get a different value for A. So let me get out of the camera. Any scalar multiple of this polynomial, is a correct answer. Think of it in terms of, I know these won't look geometrically like vectors, but it's the same kind of idea. If 2 vectors are orthogonal, if you stretch one, it's still going to be orthogonal. That's kind of what's happening here, why we're allowed to multiply by a scalar. Okay, Shutong said test 2, question 7b. Yeah, we could do that. And then we could look at question 8 also. All right, I'll give you all a second to kind of catch up with these notes. All right, 7b. We might need 7a to start. Oh, no, we don't need 7a. Nice. 7a was kind of a pain. Just because there was a lot of fractions that I wasn't anticipating. Okay, so we want to find the B matrix of T. So we were given B equals so B was the set was this basis for R4, and T was the map that sent A, B, C, D to B, 2C, 3D, 0. And the question is, find the B matrix of T. Okay, so anybody in the chat want to remind us how to find the B matrix of a transformation? Also, this is a good time for me to plug my YouTube channel. I believe I have a video that works out a question similar to this. So if you want to see another practice problem, finding the B matrix of a transformation, it's in that playlist, the Coffee and Linear Algebra playlist. Okay, so does anybody remember how to find the B matrix of a linear transformation? And please look back in your notes or look in the book. Basically, I'll remind you what we're trying to do. We want to find the image of these. We want to find the B coordinates of the image of all the basis vectors. Is that an emoji typo? That's hilarious. Yeah, find T of each vector, and then we want to make the B. We want to find the B coordinates of those vectors. Yeah. So let's. Okay, so T of 1, 0, 0. T of 1, 0, 0, 0 is 0. It's all zeros. T of 1, 1, 0, 0 is 1, 0, 0, 0. T of 1, 1, 1, 0 is 1, 2, 0, 0. And T of all ones vector is 1, 2, 3, 0. Okay, so what we want to do now is we take the augmented matrix whose first four columns are our basis vectors. And whose next four columns are the images of the basis vectors. And we want to row reduce this until we have the identity matrix Okay, we want to row reduce until we get the identity matrix, and what's left on the right is the B matrix of T. Okay? So we want to row reduce this, and basically what we're doing is we're finding the B coordinate vector of each of these images. Right, we want to write each of these columns or each of these images in terms of our basis vectors we started with. Okay, and so what this works out to be is, I'm not going to do all the row operations right now. It works out to be this. And so you could check. Is it true that 0, which corresponds to this column, is 0b1 plus 0b2 plus 0b3 plus 0b4? Yes. Is it true that this entry is equal to 1b1 plus 0b2 plus 0b3 plus 0b4? Yes. Is it true that this vector is 2b2 minus b1? Well, 2 times this vector minus this vector gives us this vector. And then similarly, is it true that 1, 2, 3, 0 is equal to 3 times the third vector minus the second vector minus the first vector? Yes, it is true. So that's how you check your answer at the end. So these are the B coordinates of the images. Okay, and Shutong asked for a second one, I think, right? Are we happy with this answer before we move on? Okay, I'm assuming the silence is a good thing. Okay, so we have, for number 8, A is the matrix. A is the matrix 5, -12, 12, 5. We want to find the eigenvalues and a basis for each eigenspace. Okay, so how do we do this? How do we find the eigenvalues and a basis for the eigenspaces of a matrix? So we'll start with the eigenvalues. How do we find the eigenvalues? Set determinant equal to 0. Yeah, determinant of a minus lambda I, right? Right, because the determinant of a is just a fixed number, so we couldn't set that equal to 0, but we could set the determinant of a minus lambda I equals 0 and figure out which values of lambda will make the determinant 0. Okay, so this is 5 minus lambda squared plus 144, which is lambda squared minus 10 lambda plus 169, and we want to set it equal to 0. So the way we solve this is the quadratic formula. Lambda equals 10 plus or minus the square root of 100 minus 4 times 169. All over 2. Which gives us the two eigenvalues are 5 plus 12i and 5 minus 12i. And so now we want to find a basis for each eigenspace. We just take one eigenvalue at a time and work it out. In fact, since the eigenvalues are complex conjugates of each other, we had a theorem that said the bases for the eigenspaces are going to be complex conjugates. So really, we only have to do one of these, and then we get the other one for free. So we'll just do out one, and you could practice. You could do it for practice to find the other one. So let's start with lambda equals 5 minus 12i. A minus lambda I is the matrix 12i, 12 minus 12, 12i. And we want to row reduce this. So does anybody remember, how do we get rid of the I? How do we get rid of the I in the top left entry? Multiply by the complex conjugate. Yeah, exactly. So here the complex conjugate would be negative 12i. Okay? So this top row becomes (144) minus 144i minus 12i. And then we could divide the top row by 144. And we'll divide the second row by 12. Okay, and now notice if we add the first row to the second row, it goes to 0. Okay, so this tells us that x1 plus ix2 equals 0. Equals 0. So x1 equals minus ix2, or x is equal to minus I1 times x2. So a basis for our eigenspace would be minus I1. Okay, and then for free, because we have a theorem that tells us this, when lambda equals 5 plus 12i, so the complex conjugate, the basis will be the complex conjugate of this basis element. Okay, so you could go through the math on this one if you don't believe me. But yeah, it works out like that. Is there anything else we want to talk about? We got 9 minutes left of class. So sad. Any other questions or thoughts? Any thoughts about the class as a whole? Anything you want to reminisce about? Don't forget to smash the like button for extra points. I don't know if I could be handing out points like that, but it's definitely good luck. It is definitely good luck to smash the like button. I'll have to keep watching for the simultaneous sips. No problem, Sam. Thanks for putting in the hard work. It was a tough semester for everybody. You know, it took some time to adjust to the online online situation, but I think we did it. I think we did it all right. And credit to you guys of still working when you're not at college. I mean, I was thinking to myself when I was in college, if I went home and had all this work to do, it'd be really hard to be able to focus and get it done. So credit to you guys for still being able to put in the hard work. I know you'll all do well on your finals. And then in the fall, hopefully it's back to normal. At least hopefully it starts back to normal. But if there's no other questions, I guess we could end class. So I don't know what my plan is for office hours for these next few days, but just if you want to meet, just send me an email and we can meet over Zoom. I think that's probably the best option. Because sometimes we have office hours and nobody comes. I just sit and do nothing for an hour. So I'd rather just you email me, we'll set up a time and we can meet one-on-one. I think that's probably our best option. So just as a reminder, Sunday at 3 Eastern. So I'm sorry to you folks that are in time zones that are way off from Eastern Standard Time. That's going to be the middle of the night for you. But while we're sleeping that night, Sunday night, you'll have time to work. So I think it all averages out. So Sunday at 3 is when I'll publish the test, and then you'll have 48 hours to complete it. It should not take you 48 hours. But that'll give you plenty of time to work out the problems. Check your answers. I'm not going to hide my YouTube videos. They're still going to be published. So, make sure you're doing the questions correctly. Check your answers with the book also. Make sure you're doing the process correct. It's really not too much of an excuse to not do well. Okay. And then, when it's 3 o'clock on Tuesday or maybe 2 o'clock on Tuesday, start taking pictures and getting ready to upload it as a PDF to Canvas. Make it nice and easy for me to grade. That'd be the dream. All right, if there's no last questions, I'm going to end the stream. Bye-bye.